Processing offers us a bunch of nice shortcuts for drawing simple shapes like lines and triangles, boxes, even general four-sided shapes. But of course, sometimes we want to draw shapes that have lots of edges and lots of points in them, and processing lets us do that too. In general, anything we make out of points and lines is called a shape, and processing gives us a very general way to draw any kind of shape. We've seen a few basic shortcut commands. There's line, and it helps us draw a line between any 2 points. Triangle, which obviously draws triangles. Rectangle for drawing boxes. And quad for drawing any kind of figure with 4 sides. If you want to draw any of these, or anything with more than 4 sides, you can use begin shape, end shape. These are 2 calls between which you name all of the points of your object. So begin shape and end shape are kind of the general purpose version for drawing all of these things and anything else. It can take as many points as you like. So if you want to use 8 points, you can make a stop sign. If you want to use a whole bunch of points, you can make a corporate logo. And if you want to use a whole ton of points, well, you can even make a bear. So let's see how begin shape and end shape work. There's really nothing to it. Here's a little sketch I made on a piece of graph paper where I've created an 8-pointed shape. And you'll notice that it crosses over itself. Processing is just fine with that. So let's see how to actually get processing to draw this shape. We begin with a call to begin shape, all one word with a capital S in the middle. It takes a pair of parentheses, like all of these function calls we've seen, and a semicolon. But nothing goes between the parentheses. They have to be there, but there's nothing in between them. So just type this line as you see it. Begin shape, open paren, close paren, semicolon, and you're golden. Now, let's jump to the end. The way you stop defining your points is to call end shape. And again, all one word with a capital S in the middle. And between the parentheses, you can give it the word close. Again, all one word, all caps. If you do that, it joins up the last point in your shape to the first point. Typically, shape will draw the outline of your shape. So it draws a line from point 1 to point 2 to point 3 to 4 to 5 to 6 to 7 to 8 in this example. And then by saying close, it will draw a final line for you from 8 to 1. You can leave close off, and you'll see what it does. It just leaves off that last line. Almost always, you're going to have close in there. So now how do we define our points? We just give a whole list of calls to a routine called vertex. Vertex is mathematical talk for point. And so it's the word vertex, all lowercase, pair of parentheses with a semicolon at the end, and we just give it the x and y values of the first point. And then we give another call to vertex with the x and y values of the second point, and the third point, and the fourth point, and we just list as many points as we want until we get to the 8th point. And then we call end shape. And so I'll just put 3 dots in there to indicate we have calls to vertex 6 more times. And you can have as many calls to vertex as you like, each one creating 1 point. Now in this slide, I wrote x1, y1 for the first point. So let's replace this with a couple of real numbers. Looking at the sketch, if we assume each one of those little boxes is about 10 by 10 pixels, it looks to me like point 1 is landing at about 65 units to the right and 35 units down. So if I were to type this into processing, I would actually enter those numbers. And just to sort of complete the thought, if we look at point 8, again, just kind of eyeballing the picture, it looks to me like point 8 is at about 145, 125. And so those are the values I would enter when I actually typed a vertex. And all the points in between would have numerical values as well. Of course, these can all be variables if that's easier for you. I just wanted to show you how you would actually type in the actual numbers if you had them. In this example, and in fact in my real code as well, I indent the lines between begin shape and end shape. You don't have to do this. This is another of those formatting things that processing doesn't care about, but I find it makes the code much easier to read and understand just visually, at a glance, to have the lines between begin shape and end shape indented. So let's see this in action. So here's an 8-sided shape loosely based on the drawing we just saw. I've got big circles at each of the points or vertices, so I can grab them with my mouse and move them around, but let me turn them off just so that you can see the shape. So I've called begin shape. I gave it 8 calls to vertex, one after the other, giving it the XY of each of these points, and then end shape. And I actually called close, which is why we see lines between each pair of points. So let me show you our drawing options. Obviously, I'm filling this. I can turn off the fill, and then we just get the stroke. Or I can turn off the stroke, and we get just the fill. If we do have the stroke turned on, we can make the stroke nice and thick. And here you can see an interesting feature of using begin shape. It does something interesting where points join up. You can see these long pointy bits where the shape is turning sharp corners. There's an option called stroke join that lets you change the nature of how points join up inside of a begin shape end shape call. Let me run through the options for you here. Keep an eye on the vertex in the upper right corner. I'll change to the second mode, and you can see it flattens off the pointy bit. And so this is just a different drawing style. And I can round everything out, which is also another nice drawing style. This is the default. And there is a video on stroke join if you want to see how to control these and what they do. So let's turn the circles back on. Tell you what, I'll make the lines a little bit thinner just so that they're not so overwhelming. And I'll turn the circles back on. And you can see I can move all the vertices of the shape around just by grabbing them. And processing doesn't mind if these things overlap one another. They can overlap one another in crazy ways. And it does its best to try to color them in some consistent fashion. Now you'll notice that sometimes the what gets filled in and what doesn't get filled in might surprise you. Like, what's going on in that triangle in the upper left? Why is there nothing inside there? Well, it's obeying a rule that tells it how to color things in. And the rule is kind of complicated, and I'm not going to get into it here. Just be aware that if you draw these really weird, complicated shapes, that things will get colored in a predictable way, but maybe not the way you were expecting. But if you're drawing a shape that doesn't have all this crazy overlap, I'll tell you what, let's kind of straighten this out and just make a nicer, unsurprising shape here. There we are. So now this doesn't have any surprises. It's not particularly interesting, but it doesn't surprise us at all. But I can do whatever I want to this shape, and processing doesn't mind. So this is the key to drawing shapes with any number of sides. You call begin shape, you list all of the vertices, and then you call end shape. And let me turn those circles off again. And you can see I'll run through the different styles for the joined up lines again. And actually, here's the rounded lines. I think they look kind of nice. Let's make them really thick. And we get this nice rounded stroke. And if I turn off the fill, we get this nice looking stroke. And I can turn the fill back on and turn the stroke off entirely. Make it so thin we don't see it. And there's just the fill. And so using begin shape and end shape, you can make objects with any number of sides.